So picking up where we left off, we had a 300 ohm resistor, which gave us 2 volts across the LED with a current of 10 milliamps, and we had a power consumption of 20 milliwatts. So what would happen if we drop that resistor to a lower value? Instead of being just above the threshold voltage, the voltage will rise, but the current will increase greatly. These are values similar to what we found in the lab. We can calculate the power using I times V, which is 0.11 watts, or 110 milliwatts. Now you can see that with a 10% increase in voltage, we can easily get a 5-fold increase in the power, which is why the LED will burn out if you overdo the voltage. And just in case you were wondering, this works out to be 56 ohms, solved from this information which we would have measured in the lab. This is the way we've been drawing schematic diagrams, but there's an alternate representation. The battery is sometimes represented by a circle, and that's a voltage source. The circuit is completed by connecting the other end to ground. That's where you have a large source or sink of charges. Either way you draw it, it really represents the same circuit. So using this new representation, what do you think would be the difference between putting the resistor here or putting it there? Does it make a difference if the resistor is before or after the LED? Let's say the voltage source was 5 volts and the LED was designed to operate at 2 volts. The resistor would still have to have a drop in voltage of 3 volts. And that would be the same if we put the resistor before or after the LED. But some kids say, but still, don't you have 5 volts touching the one side of the LED? That's true, but the other side of the LED does not go to 0 volts. It's dropping to 3 volts. And then the 3 volts drops to 0 across the resistor. So remember, it's the drop in voltage that matters, not the voltage before the LED as compared to ground. Let's analyze this situation. You're an electrical engineer and you've designed a circuit with buttons that when you press a button, the LED lights up. Each LED requires 2 volts, draws 10 milliamps at that voltage. We're going to need a 300 ohm resistor. But what happens if you close the other switch? If you think you're going to get a 2 volt drop and another 10 milliamps of current, think again, because both of those currents are going to have to pass through that resistor. The voltage drop would have to increase going across that resistor because there'd be more current flowing through it. The voltage drop across the LED would then decrease. And of course, your current would be reduced. The LED would not be as bright. So this is not a good idea to design a circuit like this. The solution is that each LED gets its own resistor. We have red, green, and blue diodes for you to experiment with. How do you think the threshold voltages will compare? The minimum voltage to barely see any light. Think about the colors. Hopefully you can do the lab and find out. What do you think a circuit like this would do? If we hook this side up to positive and that side to negative, the current would flow through the top LED. If we reverse the polarity and make positive on the right and negative on the left, then the current will flow through the bottom LED. That's because diodes only allow current to flow one way. This could be a detector. You could use it to detect which way the current flows and therefore tell you which side of the circuit is positive and which side of the circuit is negative. This might be handy when we study magnetism and we have changing currents. So the LED should be connected with the long electrode as to the positive side of the circuit. A reverse polarity can only be tolerated to a certain degree, just like the forward voltage can only be a certain amount before it burns out. So be careful how much voltage you use on these LEDs. If you burn any out, you can always order more online. They're not very expensive.